Two charges, positive negative 5 microcoulombs, are placed 5 mm apart. Determine electric field at a point x-axis of a dipole 10 cm away from its center O in the side of positive charges as shown here. Now two charges, that is negative 5 and here it is positive 5 microcoulombs, and the distance between these, which is how much, that is 5 meter apart, that is only. Now here we need to calculate the here electric field, and since the positive, the test charge has been kept in the axial axis, so we need to calculate electric field in the axial, which is equals to what we are having formula, that is K 2 P over R cube. Here K is a Coulomb's constant and we know that value, that is 9 into 10 raised to the power 9 Newton meter square C square, that is Coulomb square, into 2. And here P, what is P? P is a dipole moment. So first we need to calculate the dipole moment, and for that we are having formula, that is product of 2L into Q. 2L is nothing but here the distance between these charges, that is 5 mm. So we need to convert to the meter here. So I'm going to multiply it by negative 10 raised to the power negative 3 to convert to the meter here. Now Q is the charge here, and the charge which has been given the microcoulombs, so we need to convert to the coulombs. So for that we need to multiply by 10 raised to the power negative 6 coulombs here. Okay, now here negative positive, it has been said, it says only whether it is negative charge or positive charge, but whenever we are writing the formula, the value only we have to write. Okay, now here 5 times 5 is 25, multiply, and here the powers we need to add, so I'll be getting 10 raised to the power negative 9 coulomb meter here. Now I'm going to substitute this value here, that is 25 into 10 raised to the power negative 9 coulomb meter. Okay, now in the denominator, that is R cube, that is which R cube, this is the distance between from center of this one O to this charge. Now here it is in the centimeter, again we need to convert to the meter, so I'm going to multiply it by 10 raised to the power negative 2 and here raised to the power 3. Okay, and here we'll be getting meter, also we need to multiply 3 times, so meter cube will be getting. Now from this meter square and this, it will become meter cube, so this meter cube and this meter cube, it will get cancelled here. Now this 1 coulomb and this 1 coulomb, it will get cancelled here. Now whatever the rest of the numbers, I'm going to multiply here. Okay, now here 9 times 2 times 25 here, that I'll be getting 450, and here this is plus 9, this is negative 9, it will get cancelled here, and what we left in the numerator, we left with the Newton here over. Now 10 we have to multiply 3 times, or else I'm going to write it as a 10 raised to the power 3, and here 10 raised to the power 2 times 3 is negative 6, and what we left in the denominator, we left with the coulombs here. Now in the next step, 450 over this, the bases are same, so what we can do, we can simplify with the powers, and I'll be having negative 3 Newton coulomb here. Okay, in the next step I'm going to shift to the numerator, so I'll be having 450 into 10 raised to the power plus 3 Newton per coulomb here, and this we can multiply, so I'll be getting, that is, here it is 3 zeros, 1 2 3, let me add here, so we'll be getting 4,50,000. so instead of writing like this, so we can write it as a 1 2 3 4 5, so I'm placing here the decimal point. Okay, and into 10 raised to the power 5 newtons per coulomb here. And in that another question, that is determine electric field at a point Y which is 10 cm away from the center of O on line passing through the O, and then this line is normal to the axis of the dipole here. So let me draw here, this is the what we had, negative 5 microcoulomb, and here is the positive 5 microcoulomb, and the distance between these two dipole was a 5 millimeter. Now this is our center O. Okay, now they are saying here the line which is passing through this center. Okay, so here is the point Y, and the distance between this is how much, that is 10 centimeter. Now here we need to calculate the electric field in a equatorial, that is, okay, which is equals to, we are having formula, that is K P over R cube. The K, again the Coulomb's constant, I'm going to write the values, 9 into 10 raised to the power 9 Newton meter square C square, and the dipole moment we have calculated in the first question only, so that we found, that is 25 into 10 raised to the power negative 9 coulomb meter it was. Okay, now here R cube, this is since it is in a centimeter, we need to convert to the meter, so I'm going to multiply it by negative 2, okay, raised to the power 3, and here meter also we need to multiply 3 times, so it will be getting, that is meter cube here. Now from this meter cube, it will get cancelled, and 1c and here 1c, it will get cancelled, here plus 9 and this negative 9, it will get cancelled, so we left with the 9 into 25. So when I'll multiply, I'll be getting, that is 225, and here we left with the Newton in the numerator. Now here 10 raised to the power 3 into 10 raised to the power negative 6, here in the denominator we are having coulomb. Okay, again I'll simplify here, 225 into, now see here the bases are same, so we can add the powers here. Since it is having unlike sign, so after subtraction I'll be getting 10 raised to the power negative 3 here. I'm shifting to the numerator, so I'll be having 10 raised to the power positive 3. Now I'm going to multiply this with the 225. So I'll be getting how many zeros are there? 3 zeros are. I'm going to write like this. Now, so let me place a decimal point here. 1, 2, 3, 4, 5. Let me place here. Okay, not here. So I'll be getting that is 2.25 into 10 raised to the power 5 Newton over Coulomb here. Okay.